Howdy AGP students. This lesson will begin the geometry portion of the course and cover everything you need to know about angles. We'll begin by looking at a circle. A full circle measures 360 degrees. In this figure, the angle shown is 20 degrees. The marked angle would then be the result of 326 minus 20 degrees. So let's calculate that real quick. 360 minus 20 degrees equals 340 degrees. So this angle here is 340 degrees. Now let's move on to a straight line. A line would cut a circle's angle in half, which would give us a measure of 180 degrees. So this area here would be half the circle, and that total measure would be 180 degrees. In the figure below, we can use the backdoor strategy, and it would be really easy to figure out what each of those values were. Always remember to ensure that the numbers you select when using the backdoor strategy meet the constraints of the problem. In this case, 3x plus y plus x have to equal 180 degrees. For the backdoor, we could choose x equal to 35. When we do that, we can then find x times 3, and let's do that real quick. If we select 35 times 3, that's going to give us 105 degrees. So we know that 3x plus x is going to be 105 plus 35, and that's going to give us 140 degrees. Now, since this is a straight line, we can then subtract 140 degrees from 180, and that's going to give us the value of y. So let's do that real quick. 180 minus 140, that gives us a value of 40 degrees for y. We'll now move on to vertical angles. When two lines intersect, they form what are called vertical angles. These four angles have a unique property. So two of the angles will be obtuse angles, or angles greater than 90 degrees, and two of the angles will be acute angles, or less than 90 degrees. And as you can see in the picture below, the acute angles are across from each other, and the obtuse angles are across from each other. So these angles will always equal one another. Next, let's look at lines that continue on forever without intersecting. These are called parallel lines. On the SAT, parallel lines will always be stated. Don't assume two lines are parallel unless it is stated. It's very important that you do this. The test will always also tell you when lines are perpendicular as well. When a line is perpendicular to another line, they form a 90-degree angle, or a right angle. This will always be indicated on the SAT, either stated in the problem, or the little triangle symbol or the square symbol will be in the corner connecting the two perpendicular lines. A line that passes through two parallel lines is called a transversal. The same properties of intersecting lines apply here as well. Remember, since the lines are parallel, the acute and obtuse angles formed are equal on each parallel line. When two transversals intersect parallel lines, you can use a z to relate the angles. The angles forming the z are equal to one another. So you can see that in this example here, we have a z, and so this angle is going to equal this angle. Now let's look at a basic triangle. Typically, triangles will be identified with a triangle symbol followed by 3 points that are included in the triangle. The three interior angles of a triangle will always add up to 180 degrees. Below, we can find the missing angle by subtracting the two known values from 180 degrees. So here, we know that we have 100 degrees and 30 degrees. So we'll subtract those from 180 degrees, and that's going to give us the missing angle of 50 degrees. You can do this with any triangle. Now let's look at a triangle that has two equal sides. When the two sides of a triangle are the same length, the triangle is called an isosceles triangle. Since the two sides have the same length, the two angles formed on the equal sides and the unequal side are the same length. So if you look at this figure here, these two sides marked with the symbol here indicate that they are equivalent, and so the angle formed here and the angle formed here are also equal. So this is a neat property about isosceles triangles. Next, let's look at a triangle that has all equal sides. When all the sides of a triangle are the same length, the triangle is called an equilateral triangle. Equilateral triangles have equal interior angles as well. Since the interior angles must equal 180 degrees, they will always be 60 degrees each. For equilateral triangles, the area can be easily found by using the formula side squared times the root of 3 divided by 4. And this works with any equilateral triangle. And it's just a special formula. You don't necessarily have to memorize it or know it, but if you do, it could help you while taking the SAT. When the sides of a triangle have 3 different lengths, it's referred to as a scalene triangle. Since the sides are all different lengths, also the angles will have different measures. The next shape we'll look at is a quadrilateral. The interior angles here will always equal 360 degrees, since the shape becomes 2 triangles when a diagonal is placed between 2 points. As the number of sides increase, the interior angles will also increase by 180 degrees for each additional side. You can easily find the measure of the interior angles by dividing the shape into triangles. Here, a pentagon is divided into 3 triangles, giving a measure of 540 degrees for the interior angles. Let's take a look at our first example. This problem reads, if AB equals BC and the marked angle is 310 degrees, what is the value of x? Since we're given that the marked angle is 310 degrees and that the segments AB and BC are equal, we can find all the interior angles of the triangle. Next, we can then find x by using the properties of a line. So let's go ahead and do that. First, we have 310 degrees. So we can find that top angle by subtracting 310 from 360 degrees. So we'll do that real quick. 360 minus 310, that's going to give us a value of 50. Now that we know that top angle, we can then find the lower 2 angles because they'll actually be equivalent. So we'll take 50 from 180, and we can do that real quick. So 180 minus 50 equals 130 degrees. But that's for the sum of both of these angles. Now we can divide that in half, since we know that this is an isosceles triangle, and so each angle is actually 65 degrees. So since we know that, we can actually then find the value of x, because x is just 180 degrees minus 65. So let's go ahead and do that. 180 minus 65, and that's going to give us a value of 115 degrees. So when you subtract 65 from 180, that gives us 115 degrees, and that's actually the value of x, which turns out is answer choice C. So answer choice C is the correct answer. Our next example reads, in the figure shown, line AB is parallel to line CD. So line AB is parallel to CD. Which of the following expressions gives the value of x in terms of y? Here we can use the backdoor method to solve this problem, since we have variables in the problem and in the answer. Here we know that 60 minus 6 added to 2y plus 30 must equal 180 degrees, because this angle plus this angle is going to equal 180 degrees, because this is a transversal, right? And so you have your obtuse angle here, these are equivalent, and the acute angle here and the acute angle here are equivalent. So this essentially says that 60 minus x is the same here. So we add those two, and we should get 180 degrees. We begin by selecting a value for x. Here we can choose x equals 10. Since x equals 10, we can plug it into this equation here and find the value of this acute angle. So here we'll do 60 minus 10, and that's going to equal 50 degrees. So we know that this angle is 50 degrees. Since this angle is 50 degrees, we can now find the value for 2y plus 30 by subtracting 50 from 180 degrees. So here you see that 180 degrees minus 50 degrees is 130 degrees. So that means that 2y plus 30 is 50, or rather 130. So now let's just solve for y, and we can then find the value of y. So here we have 2y plus 30 equals 130. So now we'll subtract 30 from 130, and so that'll give us 130 minus 30, and that's going to equal 100 degrees. Now we divide this in half, and that's going to give us y equal to 50 degrees. So now we can actually go and plug these values into our answer choices and find what value actually gives us the answer of 10. We'll start with answer choice A. So here we can plug in 50 into the equation 2y minus 90. So first we'll multiply 50 times 2, that's going to give us 100, minus 90, and that gives us 10. So answer choice A checks out, but because we're using the back door, we need to make sure we plug it into all the answers and make sure we don't have any of the answer choices are the same. So let's move on to answer choice B. Here we'll plug in 50 into 30 minus 2y. So we'll do 50 times 2, that's going to give us 100. So now we subtract 100 from 30. 30 minus 100, and that's going to give us negative 70. That's not 10, so we know that's not correct. So let's move on to answer choice C. Answer choice C is y divided by 2 plus 30. So let's go ahead and do that. So our y value was 50 divided by 2. That gives us 25. Now we're going to add 30 to that, and that gives us 55. Also not 10, so let's go ahead and move on to answer choice D, and that's 90 minus 2y. So for this, we'll multiply 50 times 2, and that gives us 100. So now we'll subtract 100 from 90. 90 minus 100, that's going to give us negative 10. Also not the correct answer. So let's go on to answer choice E, and that's 2y plus 30. So here we'll multiply 50 times 2, and then add 30 to that. So that's going to give us 130. So answer choice A was the only one that came up with our x of 10, and so we'll go ahead and select answer choice A and move on. Now let's look at example problem 3. Here, the problem states, in the figure shown, what is the value of x plus y? A 50, B 75, C 100, D 110, or E 130. So take a minute here, try to work this problem out, work through it, figure it out, and see what you come up with. We'll go over it in class.